The first fossil fuel that we're going to talk about today is coal. There is a lot of coal in the world, but it is dirty. So not only when you burn it, of course we know that, but also just handling it. It's very dirty. Black lung is a real thing. All of that particulate matter really gets into the lungs. Unlike other fossil fuels that can do that to a human, just through extraction. Not only that, but it's also super inefficient. So when we do burn it for energy, we don't get that much energy from it. And so this coal is burned in power plants and generating about, a good chunk of the electricity of the world. But here in Connecticut, we actually don't burn coal as much as we used to. So there's only one coal plant remaining in Connecticut up in Bridgeport. You've definitely seen it. This red and white stack. Remember, these stacks go high, so that way emissions can go up into the atmosphere to get further away from the source, so that way it can get dispersed. Remember, the solution to pollution is dilution, but not really. And so we have actually converted a lot of our coal plants into natural gas, as is a lot of companies doing around the country and the world, because natural gas is a lot cheaper to run, it's a lot cleaner, and so natural gas is really the main source that companies are burning these days for electricity. The other source that we have in Connecticut is also nuclear. So the U.S. has about a little over a quarter of the reserves of the world that we know about. And here you can also see where else in the world there are some coal reserves. So here in the United States, there's a big chunk. And again, up in Russia is a big chunk, down in Australia as well. So there are 4 stages of coal. So pretty much you have fossilized plant matter that is pressurized and heated just through time. And if you take all of that plant matter together and press it and heat it up, you end up with peat. And so peat is actually not considered coal. It's just, it's just kind of compressed plant matter. With heat and pressure, you end up with lignite, then bituminous coal, and finally anthracite. So the coal that we see the most is actually bituminous. And bituminous has a pretty high sulfur content, whereas anthracite is a very low sulfur content. So this is like the gold standard in anthracite. In coal. Anthracite is low sulfur content, also has low moisture content, and so it actually is more energy efficient. So on this side of the scale, you get a better burn, or on this side of the scale, it's definitely not as efficient. So the largest coal burning countries are China, the United States, and Canada. And so if you look at the difference between China and the United States, it's actually quite different, somewhere around the year 2000, 2003, right? It's really changed. We're starting to drop down, and as is China now. So this is a dated graph. China has really made massive efforts to cut their carbon emissions. So I should probably update this graph. So again, like whenever you combust anything, whenever you set something on fire, you're adding oxygen into the mix. So we're taking that carbon and we're adding oxygen, and that will give us carbon dioxide and energy. But the problem is the impurities. So the impurities are what's causing the pollution. Because remember, carbon dioxide is not considered a pollutant. So sulfur and nitrogen oxides end up out into the atmosphere. And like you guys know, you have acid rain, smog. You also have heavy metals like mercury that go out into the atmosphere that are then deposited or precipitate out. And then there's particulate matter, which is also very much not a good thing. Coal has severe air pollution, very dirty. The sulfur releases sulfur dioxide, large amounts of particulate matter, lots of carbon dioxide, and small amounts of heavy metal like mercury. But it's cheap because the environmental costs are not included. So if we were to add on the cost of what it was doing to our environment, coal would be really expensive and people would be less likely to use it. So if you look at the amount of energy produced so if we say that the amount of energy produced when you burn coal is at 100%, and looking at other forms of energy that we can get from other sources, um, this graph is actually showing in relation to how much energy we get from coal, if that makes any sense. So we're not going to get as much oil energy from oil if we burn it, or natural gas. So that means that in order to get as much energy, you're going to have to burn more. So if we were to maybe fluidize or liquefy the coal, you actually end up increasing your energy. So after you burn coal, you're left with ash if you collect it, right? And it is, even if you don't collect it, it's still left over. But even when you do collect it, you have even more. And it has lots of heavy metals in it: arsenic, cadmium, chromium, lead, mercury, and all of that is left over after you burn it. So some farmers use it as fertilizers, and I don't know about you, but I don't want heavy metals in my fertilizer. But it actually gets buried in ponds, and in doing so, if there's some sort of break in the containment of the pond, it can really contaminate groundwater or even a nearby river. So here's a little video about this coal ash pond actually was compromised in some way and spilled into the local river. So it wasn't a pretty story. If you're interested in that, you can check that out. The coal people are trying to build clean coal, and in clean coal, right, you're washing coal of its sulfur, really, or even just physically washing it to reduce particulate matter. But you're not actually reducing all of the sulfur out of the coal, and so these companies are fighting against the things that can put protections into place, and they are trying to build coal as not dangerous. And so how do we make this clean coal? So we went over scrubbers before, right? Wet scrubbers. You can have not just water, but add lime into the mix and remove that sulfur, and you end up with this sludge in the long run that ultimately needs to just be disposed of. And fluidized bed combustion is to crush the coal and suspend the coal in air, and it acts like a fluid, and they can burn it more efficiently. So ultimately, if you do that, you can add in some limestone, it can precipitate out the sulfur as well. So that's the way that we can make our coal clean. Still not very clean, but cleaner maybe would be a better name for it. And so here's a little picture about fluidized bed combustion. You can take a look. And coal can also be converted into synthetic fuels. So we can gasify it by liquefying coal and then um, increasing air temperature. And so, it burns better, but you still get a high amount of carbon dioxide out into the air, and not a very high energy yield. So coal mining obviously is an issue with coal as well. There are all kinds of issues that we've talked about before. So not only just the carbon emissions from the actual physical mining, but also just the decimation of the environment in which you're mining coal from. So that's not good either.